Hello, everybody, and welcome to Endgame Essentials. This talk will cover a lot of tools and tricks that you can use to take your code from good to great. This will not only make your code look far more professional, but it will make it a lot easier for you to maintain without having to constantly check in and make sure everything's working. And it will make it much easier for new collaborators to hit the ground running with your project. Now, let's take a look at oh my God, how did that get there? Let's take a look at the anatomy of a Python package. So we'll generally see a structure that looks a little bit like this. You might have gone through other people's repos and seen this. You might have implemented this yourself. We'll be breaking this down and taking it step by step, looking at each piece of this and how they work and how they fit together. So looking at the first part, we have the pyproject.toml. And now this is a configuration file for managing your Python project builds. Some of you might be a little familiar with setup tools or setup.py. This is a sort of newer, more modern version. Some of the key components will be just this project section up here. You'll see some very important metadata. And this is just a really helpful configuration file that will collect that all, and it's imperative for if you're going to package your project and put it on PyPy or the like. And going to setup.py, that used to be the standard way that you would set up your Python packages. However, it is an executable file that you need to run in order to identify the dependencies that you'll need to install in order to execute this executable file. And ultimately, that can get a little bit of a mess and at times just simply not work. So there has been a general switch towards pyproject.toml. There are special cases, like if you're supporting a lot of legacy code or you need complex or custom builds. For example, I was just working on a project where we are wrapping C++ code. We will have to have the setup.py around while still using a hybrid approach where we do provide the pyproject.toml. But in general, it's nice to just prefer the pyproject.toml. Looking at the license, what are they? They're documents that grant permissions for using, modifying, and distributing software. How do they work? They specify the terms and conditions under which the software can be used, modified, and shared. Different licenses have different levels of permissions and restrictions. And why do we use them? To define the code that can be useful for, how the code can be useful for others, and to protect our own rights. And it's also easier to collaborate with people if you already are on the same page about how the code is used, how you can use it in the future, what your sort of bottom line is with how you expect this to be distributed. Most common licenses are listed here. You'll especially see the MIT a lot. If you're not familiar with copyleft, that's like essentially just requiring everybody that uses the code to then make other stuff with it to then keep it open source as well. So these are probably the ones you'll end up using in astronomy. Please correct me if I'm wrong. Maybe there are some special cases. And if you don't have one, you can still use your own code. But without a license, other people can't really use it. So it's just a good practice to always have one in your repo, no matter what. If you are a little bit unsure what license you want to use, I highly recommend this website. It's very helpful. You can just go through explanations of all of them. It simplifies the process for you. It's just really, really a work of genius. And now the source. This is a common structure where you will put the actual code that's doing things into this source directory and then the name of your package. And then in here, you'll have all of your script.py files. This keeps it bundled up and away from a lot of these other kind of utility functions. And when you end up distributing your code, you end up only distributing this stuff in here, which is very convenient. But now looking at the code itself, how do we have good style? And what's the point of having consistent style? This will make your code overall more readable, but it'll also provide visual cues. Using conventions like Pascal case for class names helps you instantly recognize classes. If you're just scanning things through and you see Pascal case, you can just be like, oh yeah, okay, that's a class name without having to read any more context. Collaboration, this is kind of a nice to have. It's just nice to collaborate and be on the same page with everything, but it is also a bit of a threat as you're going to be working with people who use linters. It's going to be more and more common that they will be maintaining certain style guidelines. So it is a good idea for you to go ahead and build these good habits now, because in the future, some of your collaborators might just make you do it anyway. It also makes it a lot easier to just kind of have the same styles that when you're going in on your code, maybe somebody's using single quotation marks in their code, but you're using double, and then it just looks gross, and you have to conform to their style. And it's just nice to be on the same page. It makes everything look a lot better. And now linters. What are they, and what do they do? They'll perform static program checking. So they won't be running your code, but they'll be taking a look at it beforehand. They'll look for errors, anything that's violating any standards, and code smells. And that's when things aren't exactly wrong, but maybe things could be improved. It just gives a sort of funny feeling. Linters will help catch that for you. It also is really nice when you're reviewing someone's code. If they've linted their code ahead of time, you don't have to really be looking out for any style errors, and also it'll be a lot more readable. If just everybody's on the same page about this, you aren't opening a little PR comment saying, hey, this is cool, but like, have you considered maybe this little nitpicky style thing? So it's just a very convenient tool to use. Two of the most common linters that exist are PyLint and Rough. I've recently been using Rough a whole lot. It's very convenient. It also does come with some auto formatting, which is really nice. You can set this up in your IDE or your code editor, and it can, if you set it to work this way on a save, just kind of restructure things in a nicer way. It'll maybe create consistent line spacings between your functions. It'll just kind of take that piece of mental load off of your plate. But these do not look out for any sort of errors or code smells, so they might not look for weird import things that are going on. So it's a good idea to go ahead and use a linter if you're also going to be using an auto formatter. Some really helpful tools as well. I love iSort. It is a headache to memorize the rules about how you should be ordering your import statements at the top. iSort will just take care of that for you. It's such a godsend. If there's nothing else you take away from this, you should definitely check that out. And back to Rough. How would we use this? How does it work? It's pretty straightforward. You would just go ahead and you would install Rough with pip. You can just run in your command rough check or rough format. I have it set up in VS Code, so I don't actually run these commands. I'll admit, I copied them for documentation, haven't checked them. If anybody uses them and finds they don't work, let me know, and I'll alert the class and update the slides. I find it really convenient in your IDE, because it'll just sort of work within your UI, and it's really nice. It'll even sometimes suggest things with a little tooltip. You can also now, in Rough, you can choose things to ignore. Say, I want to be allowed to have long lines. You can do that either within your PyProject TOML in a little tools section, or you can just go ahead and apply that on a line-by-line basis. It's very convenient. Some of you might have noticed in one of my early demo notebooks this week, I did have a little thing like that at the top of the notebook, just so I could ignore the fact that I was defining classes multiple times with the same name. In my VS Code editor, it was complaining about that and telling me, hey, you shouldn't do this. This doesn't make sense. Very convenient, except in a demo. All right, so let's go and talk about style in general. How can we write with good style so we don't even need to be corrected by our auto formatters? PEP8 is a really good standard to be using right now. We're just going to go and run through some of the basic styles. This might be a little bit boring, but this will be a helpful reference in the slides later on, and it's just good to know it ahead of time. Indentation, we all probably know, 4 spaces for indentation level. We'll want to use blank lines. We have a certain sort of 2 blank lines before and after function definitions. And otherwise, just try to keep it to 1 so you aren't just having to scroll forever. The line length should be to a maximum of 79. If you want, in your code editor, you can set up a little ruler often that'll sort of have a little vertical line at 80 so you can see when you're going over. And of course, take this with a grain of salt. Sometimes you will need to break this guideline for instance, a long equation that just wouldn't really be readable mathematically if you were trying to then break it down into smaller lines. And a fun thing about getting pedantic about line lengths is if you do this in comments of GitHub issues, you might end up meeting one of your heroes who will blatantly tell you to just please go ahead and stop, which I think is beautiful. This man here is Guido, the guy who invented Python. He has some opinions about line length, but mostly just kind of take it, roll with it, and stop complaining about these things. Going back to PEP8, imports, there's a lot of rules. This is why I recommend ISOR. It'll handle a lot of this stuff for you. Generally, in a Python script, you'll want to keep your imports all at the top of the file so everybody knows what's going on. There's no surprise imports happening later. You'll want to use absolute imports, so try to avoid doing the from ... import, whatever. Definitely, you want to avoid using wildcard imports. If you can, this will end up importing a lot of weird, unexpected things that you aren't even aware that it's importing. It can create some circular dependencies. It's just a very good thing to explicitly know exactly what you're trying to import when you do import from a module. For string quotes, just pick it, just be consistent. That's the most important thing. White space, we have some just nice rules to follow. You can reference these later. Just generally try to keep things consistent and don't be adding white space in extra places. And then comments. This is a really important conceptual one. You want to explain why something is done, but not what is done. You don't want to be kind of putting the implementation into English, but more, hey, like not we're accessing the end of this list using by using a -1 index. That's the what. Instead, you want to say, hey, we're accessing the end of the list because we know we've just appended to the end of the list, and we know that this thing is X, Y, Z, which we're going to need in this thing. You want to keep the comments to sort of high-level conceptual explanation of things that couldn't be understood by just reading code. Inline comments, don't litter them everywhere, but they can be useful. And then naming conventions. We've mentioned this a little bit before in some of my talks. Just try to keep it to snake case. These days is the standard in Python, unless it's a class name, in which case we do Pascal case. And then constants will be all uppercase with underscores for the spaces. And then you are all scientists, so there are some considerations that you will have to make, even in the context of PEP8. Just try to kind of use your instincts. Line length, for instance, we mentioned equations might look weird if you're chopping them up. Sometimes you'll have to break this. Imports at the top, that's something we should be doing in Python scripts, but in the context of a notebook, definitely makes sense to keep them within the area where you're using that tool. So that is totally good to go with. Descriptive variable names, in general, this is kind of guarding against people. The PEP8 that describes this is guarding against people who are just making functions or like playing code golf where they're trying to use as few characters as they can. They're the people who will end up just like littering There are functions with poorly named variables of like, oh, x, but you're like, what does x do? What is this? When they could have just named it something descriptive. But we do have cases here. This is probably something you maybe haven't even thought of for a non-astronomer. RA and DEC would sort of look that way, but those are totally fine. So keep using them as you would be using them. And then things like UGRIZZY in the context of filters, yeah, that does make sense. So these sorts of things, if we conceptually think through them, does it make sense, then we can totally use those too. But just because Z is fine here in the context of a filter, you do have to think things through, like if we use this to denote redshift, is it clear that that's what's going on? Or maybe does this piece of code that we're using not really talk about redshift that much, and so maybe it'd be out of context, so you do still have to use your best judgment. When in doubt, it is helpful to just go ahead and name it something descriptive. And the most important thing, though, is to stay consistent. And that's not just within your own practice and how you've been doing it, but also when you are added onto a code base is a very good idea to just take some time to look through how they've been applying style in their code and try to follow what they're doing. If something is entirely egregious, maybe you should bring it up and be like, hey, like, how about maybe we do refactor things a little and change it, but instead of just trying to be the change that you want to see in the world, you should go ahead and try to stay consistent to the change or change it all to match. All right, so looking at, or any questions so far? I've been kind of whirling through these. Great, and feel free to raise your hand at any point. Now, looking at workflows, this is a really fun tool that I love using. It's so convenient and takes a lot of work off of your hands. GitHub Actions. These are an automation tool provided by GitHub for free, very convenient, and they'll automate workflows, which is essentially to say they'll just perform a set of tasks defined in a given file. On the right, we have an example of a YAML file that does describe a workflow that we might want to run. This is a very simple version of running CI, or basically unit tests on our repository. And standard practice is to put them in the .github/workflows directory in your repository. And they're commonly used for continuous integration, or CI. This will help automatically build and test your code every time you push changes, which is super convenient, because sometimes you'll open a PR and you won't even notice the typo. Your linter hasn't really caught anything. Even your collaborator, maybe who's reviewing it, hasn't caught it, but you can have this little stage that happens when you open the PR where these unit tests get automatically run. And they'll say, hey, we actually failed. This new change that you're proposing does not adhere to the unit code, unit tests. You should probably take a look at what's going on. That will save you so many times. And then similar things with continuous development. This is also a super convenient thing where you can just automatically deploy your code. You don't even need to think about it. It just will, there are workflows that will automatically push things to PyPy, the place where you put your Python package every time you roll out a new release. That is just a very, very nice little tool that you don't even have to think about. And then there are actions that will automatically lint and format. That can be super convenient. And then there are actions that will help automate tasks like labeling, commenting, closing issues, or PRs. You can do a lot of things. It just takes a lot of work off your plate. And for example, you can also have a pull request template. This one was a little late addition. This one wouldn't go in the workflows. This would go directly into GitHub. It's just another nice little tool that you can use. An example of it is, say, you can create a template for a bug report, and this will create a little formatted form that a user has to fill out when they're submitting a bug report. And this is so nice because it makes people give you the kind of information you want when they're putting this new task on your plate. You're like, okay, well, if you're telling me it's not working, I really need you to really explain what happened, tell me background I need, and other things that you can, this doesn't just have to be bug reports, this can be for feature requests or for any other kind of issue that a user might open. I really enjoy in Rail and a lot of other LINCC frameworks code, we do have a PR template where every time you open a pull request, you also have just pre-filled text that you have to like check off. Oh, yes.
Just going back to the continuous deployment. So I know that there's often an issue when you try to pip install something that has multiple packages with the same name. So like there are a lot of people who have made packages called Astro Tools or like tools or utilities, stuff like that. Is there an automated method as part of this GitHub Actions that will check that for you?
In order to have a package on PyPy, you will have to own just sort of like the landing page, the name of that package on PyPy. So that should be sorted out. It's why we have a case of, like with Rail, we call it Rail, but the actual package name when you're pip installing it will be pz-rail, and that's because someone else already owned Rail, and we couldn't get that. So it should, there shouldn't be issues as far as that goes. But I'd be interested to hear more about this Astro Tools.
Yeah, I'll find the example and I'll show it to you after.
Okay. Mm-hmm. And also this CD, you would have to set this up and you would have to link it to your PyPy account and stuff and like pass around the tokens. So it's automated, but only after you've told it how to automate itself. And so I love PR templates because essentially it'll give you a little checklist that you know, you should be clearing out your notebook outputs, and you should be linking your issue number in the PR description to be like, hey, I'm closing issue number 37, and you should be writing any kind of description of what's happening. We have that little checklist to make sure other people follow this kind of structure that we're trying to maintain in our pull requests. And now on to tests, everybody's favorite part of coding. What are unit tests? They are automated tests that verify the functionality of a specific section of code. Usually this will be individual functions or methods. They isolate into the smallest testable parts of an application to ensure they work as intended. So this is as opposed to some kind of end-to-end smoke test. With unit tests, we're just really trying to look at the atomic portions of the code. And this will help us make sure everything's working. It'll help us catch bugs a lot earlier than we otherwise would have if we wait for someone to use it and then be like, something doesn't look right. And this does help so much when you are refactoring code because you know that every time you make some change, as long as the unit tests are passing, probably you're on the right path. It's a very helpful kind of just thing to have as a safety blanket for sure. I appreciate just the mental frame I have when I have very solid unit tests. Now, how can I use them? I personally use PyTest. I think it's very useful. It provides a lot of functionality while being pretty simple to set up. You would just install it with pip, and you follow these kinds of organizational rules. You just have to put your test files in the test directory, and you prefix them with test, and you prefix your functions with test. And then PyTest will just read through everything in your test directory. And I think you can, in your settings, set this to be something else. I don't know when you would, but you do have a bit of control over that. And PyTest will just read through everything there, find everything that matches this, and then run each of those things as a test automatically for you. You can just run it from the command line, super convenient. If you're trying to take a look at a certain file or certain unit tests, you can just go ahead and target them directly, which is very convenient. And other useful flags to have will just affect the verbosity or show the print statements that might be made in the module itself, which would otherwise be suppressed to keep things clean. So these are really helpful things if you're debugging or just writing the test and trying to make sure everything works the way you expect it to. And then what's great about unit tests, once you have them written, you can automate your tests on GitHub Actions. The documentation is actually really excellent. GitHub does a great job at this, so I recommend just poking through that. And here we have this example, again, of just how we might run these tests. It's pretty convenient. It's really nice to just have that. And now that we know how to run them, how to install PyTest, let's take a look at how we even write these tests in the first place. We want to keep them kind of simple. You know, there's nothing wrong with having many small unit tests. That can be a very useful way to figure out what's going wrong. Maybe a little bit longer than this, but hey, who's counting? We can use asserts to just check that certain things have the values we want. We can use syntax like this to check that certain errors are being raised. And this is just a general reminder that it's good to check some values, but we do want to consider edge cases. So think about weird values like, hey, what happens with negatives or really large numbers? You want to still have a bit of your conceptual what's going on hat on when you are writing these unit tests, just to get any weird behavior that might be flying under the radar. And so a really nice thing with PyTest is the comptest.py file. This will be just right in your test directory, and this will help you centralize a lot of code that you'll want to be using throughout all your tests, largely fixtures and hooks, and you can just reuse them super conveniently. A really nice example would be just this fixture here that you might just fill this in with maybe configuration values that you often use, or maybe a just really simple bit of data that maybe you're passing around, just whatever might be used a lot throughout your unit tests. Instead of typing it out each time, you can have this here, and then if you decide you're renaming the key, then that'll be taken care of through everything that then uses it. And so onto more decorators. This is, I think, one of the most exciting things about decorators is using them in unit testing. These are two of the most popular decorators you'll see. You can, instead of having to copy and paste this many times and just hard code all of the parameters you would want to test it with, you can just go ahead and use the PyTest mark parameterize decorator, which will just put these in the way you would expect it to and check that all of these do work when they are put in as these parameters up here. Yes?
So with testing, how do you know if you explored enough variables so you're actually trying to test? So is there a convention that you should follow when trying to decide whether you explored enough of things that could go wrong?
Let's see. You can never really know. You kind of have to do your best guess. But the most important thing to know about testing is it just builds your confidence in the code, but it is not proving that anything is right. You would have to bring in a mathematician to do that. I would just take my best stab and maybe think about the Pareto principle, or how much effort can I put in for how much reward? Am I going to spend 5 days working on some tiny, tiny little edge case that won't happen? Maybe don't do that. But if you can spend a solid afternoon to take care of most of the things that might go wrong, maybe that's a good idea. Maybe someone else has different approaches, but that's how I usually optimize my unit tests. But we will come back to this in a few slides. And then for just fixtures, we can create reusable test data or just setups, just anything we don't want to have to retype. So we would define it here like that, and then we would just kind of put it in here. This can be a little bit weird to get used to, the syntax, but we just plop it in as this little parameter, and we automatically have it, and this can be defined in the comp test. You don't even have to see it, and we'll just have access to it, which is just really neat. And then PyTest timeout is a really convenient plugin. You would have to install it on top of PyTest, but this can help you if you're kind of dealing with code, maybe it's a little bit of machine learning going on, or just anything that'll take a really long time. You can kind of cut it halfway if it's taking much longer than it's supposed to. This gives you a lot more control over just the temporal aspect of how long your code is taking to run. A basic usage could look like just setting a global timeout of 10 seconds for each test. As you run things with PyTest, you just throw this flag in, and anything that takes longer than 10 seconds will just automatically count as a failed test. Or you can get a little more granular and use this decorator here, and you would just say, hey, this isn't allowed to take more than 5 seconds, and so this thing here that sleeps for 6 seconds is automatically a failure. PyTest hooks, I included this slide because I think they're pretty cool. I actually don't have any practical experience with them. I just know the theory, but it's nice to know this exists and might be something any of you want to explore in your code, but they just allow you to customize the behavior of PyTest further, and essentially, like, you can create this hook that will run at the beginning, I understand, of each unit test, and it'll just create some setup. I would recommend, if this sounds like something you would want to do, read through the documentation more. I'm not going to tell you about things that I don't actually know. So just know that these exist. Test-driven development, or TDD, this is a kind of new, or well, it's a novel approach, I guess, to development. It's a little bit backwards, maybe, if you're used to just writing your code first. It focuses instead on writing the unit tests before you write the code, which kind of helps you think about the desired behavior up front when you're approaching the code. A general cycle will be you write the test, and if you hate things that fail, this is going to suck for you because it will fail right out of the box because you don't even have the code yet. But then you go and you write the code. You try to keep this minimal, just enough to make the test pass, and then you go ahead and you can refactor the code, change it, add the features you want, as long as then the unit tests still pass. It can be a kind of interesting way to approach different problems. I think trying to do this as an exercise now and then can just kind of open your mind to just new ways of thinking, even when you program in your normal way. So if you have a spare Sunday afternoon and you're an absolute nerd, I would recommend checking this out. So what happens if I need data in my tests? I know some of you were wondering this earlier this week. So there are some approaches you can take. If it is just toy data, you can store these small and static data sets right in your test directory. A good practice to just throw it into its own little data subdirectory there. And you can then reference that. You can create a fixture in your comp test just to keep it sort of simple and access that easily from any unit test. And the nice thing about keeping things in your test directory is they will not be bundled into the source code that ends up on PyPy or the like. So you want to keep these as smaller data sets, but what's nice is they won't even count towards the actual code you're distributing, unless you're telling people to clone your entire GitHub repo, which is also a very valid way to distribute. But it's just a nice little detail to keep in mind. But if you have like larger data sets that like you wouldn't feel comfortable bundling into your repo that way, then maybe think about, hey, is this even suitable for a unit test? Maybe I want this larger data set actually for a smoke test or an integration test. Like maybe this isn't even quite at the scale of a unit test. So just like think about what you're trying to do, and you can, if you want, if it's say some curl, you're just trying not to clobber an API, you could throw that into a smoke test that runs once a night. That could be a reasonable approach to make sure you're still testing things with a large amount of data, but you're not testing it each time you open a pull request or each time you just want to check that things work. You can also explore some of the functionality GitHub Actions provides to cache these data artifacts that can help reduce the kind of API calls you're making and just make things a little bit neater. And then what does Okay, oh yeah, and then I guess this one is just an example of toy data. You would just be able to access that with this fixture, this little CSV, and then you just bring it in, and then you have it. Very convenient. But maybe those solutions don't really work for you. Maybe you would actually prefer to just make up some mock data instead. And I think this is really convenient. I think it's kind of a magical thing. I've used it a few times, and I'm still like, wow, this is like kind of wild that it exists. You basically get to just mock whatever you want. A function, a method, object class. You can even mock side effects, like, hey, this thing should be raising an error too. You can specify that. And you just use the unit test.mock library. And there are two different syntactic ways you can go about this. I recently, on my last incubator project, I was trying to do a bunch of unit tests, and I approached it with this decorator here, and it worked well at first, but then I was mocking kind of nested things, and we just ended up with a lot of decorators stacked up here, and if we remember, we start with the innermost and work our way through, so we can reason it about like which things are going where, but it got unwieldy, so that was this sort of interesting lesson in, okay, cool, I liked this decorator, but it's time to refactor and go ahead with this. It's the same functionality, it's just using context managers instead. When things get nested, then you just sort of nest more, and it can be easier to see how things are going. Just pick whichever makes sense to you. Worst case, you'll just rewrite it a little bit. But basically here, I was mocking some stuff that was making a lot of API calls to download data. And so I would just put this in here and like patch that in, and then I could just say, hey, this data that I will have downloaded from the internet will look like this. And then I was able to just get it. And just, it's very convenient. I definitely recommend learning this just enough to be able to use it in whatever unit tests come up. It saves you with any kind of API calls or just like weird sorts of, if you're trying to use other packages that you're dependent on and like they don't work quite in the way you want, it can also be useful. Well, you can use it for a lot of things. It's just super convenient. But ultimately, yeah, how do we know that we wrote enough tests? We can't, but we can at the least use CodeKev to give us a little bit of peace of mind. This is a tool that will provide code coverage reports to help you understand which parts of your code base are tested and which are not. It integrates really nicely with the CI/CD pipelines you have in place to just generate and update coverage reports. So this will basically show you, hey, maybe there are some lines of your code base that when you run all of your unit tests never get touched. They're never checked by any unit tests. These lines are free agents. Maybe, maybe they don't work the way you think they do, and maybe you want more unit tests. To set it up, you just follow a few steps. I would recommend going through the documentation, but the really exciting part is it'll just generate some really nice visuals that show you a lot of information. This is a little screenshot from one of our pull requests that has this enabled. Drew made a change, contributing a bit of unit test code, and our project coverage ended up at 63%, which is really nice. So we can just see that every time code is contributed, you get an update on, hey, 63% of your project is covered by unit tests. And this is also a really helpful reminder if you are contributing code that is not a unit test, and maybe you did not include a unit test with it, then you will see this actually go down, and it'll be a good reminder, hey, maybe we should be unit testing this when we contribute it, just so that it works, and we know that it works. And there are some repositories, some projects where people will declare a minimum amount of coverage that the repository should have. And so this helps maintain that and keep an eye to say, hey, we can't test everything, but maybe we can test 90% of our code. So having this automatic update with every PR is very convenient. And then if we go, we can look into the code coverage dashboard as a whole, and we can look through the repository on a script-by-script basis. This is an example of the LIFAR incubator code. And here, when we were going through and doing a bunch of unit tests to just buff that number up, you can just organize the column by, hey, what has the lowest coverage? What should I be working on? It's very convenient to get a sense of what parts of my repository do need a little more TLC. And also, who does not love just like little charts? In love. All right, so on to the docs section. Oh, yes.
Should we worry about testing our tests?
Who will watch The Watchmen? Yeah, I think that does sound like you might never stop then. I think in general, following the idea of trying to keep unit tests small, and say you have a function that you're trying to test, you could have 5 different unit tests saying, hey, check that this fails on this kind of input. Hey, check that this does this thing, and just break down each sort of aspect of that code into really small unit tests, which helps you to reason about them rather than having like some giant unit test where it's like, oh, well, okay, if we end up going down this branch in that method versus this branch, that can be a lot harder to make sure that the unit test is doing everything you want it to. Another good practice is just always be collaborating with someone. Don't just push straight to main, be opening PRs, and have someone actually read through the code and say, hey, that unit test doesn't make sense. But yeah, I'm sure all of us here, if we write any unit tests, will write one that just doesn't work, isn't right. Just try your best, I think. Yeah. And I think also what can be helpful is if you take some time stepping through your code cov report, maybe you're like, wait, why isn't that line covered? I just wrote a unit test for that. Then you can go back and look at your unit test and be like, oh, no, that didn't actually go into that code. And what's nice with code cov is there is some integration into the little pop-up that you get in GitHub where you can like toggle it on or off, but when you see the files that have been changed, you can see, oh, hey, this line wasn't covered by any unit tests, or like code cov didn't hit that line. So just taking a look at what lines are covered sometimes will handle that. But yeah. Sometimes they'll fail you, I guess. Good luck, I guess. Any other questions? All right, on to docs. Documentation. It is crucial for understanding, using, and maintaining the code base, and it comes in various forms. A really common one that we'll see are demos. These will be your standard Python notebooks. They're really nice, very convenient, 10 out of 10. But we do also have official docs, and these are a little bit more polished often, or you will be writing these with, hey, who's going to be entering this code base with no information? You're going to be writing them with that kind of audience in mind. So you'll have detailed explanations, usage guidelines, and API references. And it's a really fun thing to note that these are not a substitute for this. Official docs are something that cannot be fully provided with demos. I've worked on code bases where not everybody was on the same page about that, and it is challenging to onboard yourself. And oftentimes, you'll then later see other new collaborators fall into the same rabbit holes, and it's like, oh, couldn't we have had some kind of cohesive place where we could just, maybe one person makes that mistake, and then they explain it, and then nobody has to make it again. So I know it's a pain. Documentation is very annoying to write, but when your project gets to a certain size, when you're adding a lot more collaborators, you really do want to be considering, what do my official docs look like? Maybe for a new repo, that's a little premature, but there's a certain point where this becomes very important. And finally, we have doc strings. These are really nice. They're embedded in the code itself. They'll describe purpose, usage, behavior of functions, classes, and modules. So let's read the docs. They also nicely do have good documentation, as they should, because they are all about documentation. They are a platform that hosts documentation for your projects, and they will automatically build and update it as you push changes to your code, which is very convenient. Nobody wants to have to go in and use the HTML knowledge they learned from their Neopet days and just go in and, make these changes themselves. Read the docs will handle a lot of that for you. And Sphinx is the way that it does that. You will use RST files to describe the structure of pages and the sort of the information that's on the page, and then Sphinx will tie that all up with table of contents and just create a sort of mapping of the RST files to create your website for you. An example of the Rail read the docs is right here. This is just the opening page, and here is the corresponding RST file. We have the title, this table of contents. Here we can see the beginning of it right down there. And we can also see, it's nice, the sidebar generates from tables of contents that it finds, so it's just really easy to navigate. We only have to write this documentation once. We can go and update the text, but all of this stuff will be set up for us. And also, Read the Docs is free for open source stuff too, which is nice. Always a fan of free tools that still will be maintained because other people have to pay for them. Also very nice. Okay, so on to doc strings. What are they? They're string literals that you'll be putting right into your code, and they'll describe these things. There are a few different styles. We'll be focusing on NumPy style because that's a pretty big standard in scientific and data analysis communities. It provides a clear and structured format, but just know that Google style and restructured test style also do exist. Here's an example of NumPy style doc strings. We'll have this should be a one-line summary of just what's going on in this method. Then we'll have a little parameters section, the parameters, and then the type that we expect them to be. That's really nice, especially in Python. A lot of people aren't really using type annotations yet. I definitely am too lazy for a lot of my code. So it's really nice to at least have this declared somewhere, and the doc string is a great way to do that. So other people know, hey, okay, this is the kind of types that we'll be working with, and it's just tremendously useful. And then we'll show what we expect to return. You can also add a few other types of sections here. Sometimes people will have a little notes section with the same style as this, and then a little underline, and explain whatever notes. Maybe you'll be explaining a reference to some scientific function that you're implementing in this code. Maybe it's a reference to a paper. I've seen that around. Just whatever you want. Following this kind of framework, it is a tremendous tool that will take code and make it readable and just very exciting to work on if someone you're working with has implemented these already. They'll make things more readable. What's also super nice is in most code editors, if you have been writing doc strings, you can hover over the method or the object, and you'll see a little tooltip pop up that just has the doc string. And if you've used any kind of, I think it's markdown formatting. I know if you use those little ticks around things that should be code, it'll even format it for you. It is so convenient, and it's a good incentive that improves things for yourself when you're making a doc string. So at the least do it for you. What's really nice also is if you have doc strings in an interactive notebook, you can just do a question mark or 2 question marks afterwards, and you'll get this output that shows you the doc string and the source code if it's 2 question marks. So that's a really handy thing to have on hand if you're working with things that you're not 100% sure what they do. Instead of opening up a new window, going through the documentation, doc strings will save you a bunch of time. And the final really great thing about doc strings is if you're using read the docs, you can use AutoDoc, which will automatically generate documentation based on your doc strings. This is an example of the Rail AutoDoc section of its read the docs. This is like nobody has generated this. This is just all automatically happening. And it just creates this large list with a hierarchy of all of the elements of Rail, and then you can just go ahead and click this here, and you get this page that just shows an explanation of what's going on. It's very painless, very easy, and happens because we write doc strings. And finally, for your documentation, if you want to include diagrams, this is sort of a nice to have. You don't have to, but it's really convenient to know that this exists. You can use Mermaid to generate UML diagrams directly in your documentation. Up here, we have a little flowchart that we've made, and then this is how it would look. Mermaid is just a little tool that lets you just like create these in Markdown. I'm not sure if it works in all Markdown Markdown tools, but I know like I generated this in VS Code, so it's very handy. Worst case, it can be really convenient if you're just trying to use it for yourself. Instead of having to like drag and drop things in Lucidchart and stuff, you can just like go ahead and have that as text, and then you can just export the image, worst case, and put that into your documentation. And going back to UML, it's helpful for class diagrams, but it can describe many other features of software architecture, and is a really helpful way to just describe something that maybe you would have to use multiple paragraphs of words to describe, when maybe a picture would cut to the chase a little bit better. And so now, wow, Olivia, that was a whole lot. I'm not going to remember that. Yeah, I don't blame you. I wouldn't either. I don't. Instead, I use the LINCC Frameworks Python project template, or I just Google things. Both are good, you know. But if you do want to use this, we've created this specifically to help take away a lot of the mental overhead of having to remember, how do I structure my project? How do I implement the CI that I want to have? How do I set this up for read the docs? What other things am I forgetting? This is a template that uses Copier, so you just have to set it up once, and then anytime you want to grab any of the new features that us little code monkeys have been adding into it in the following months, you just have to pull in a new version of that with a single line, and it'll automatically populate the new features or any sort of bug fixes or et cetera into your repository. It's very convenient. You don't really have to know a lot of things. It just does it for you, and you can trust that it is set up. I definitely recommend, at the least, just poking through the documentation, and maybe next time you're starting a new Python project and you don't even want to think about, okay, like how do I fit this together? Maybe just go through the intro steps and just generate a project. You have a lot of control over the features that are offered. You can just do a quick start, or you can go through and say like, okay, hey, I do want read the docs documentation, but no, I don't want any linters. No, I don't want this, but I do want that. It'll take care of it for you. It's very convenient, and at the least, reading through its documentation, we do describe a lot of the best practices of these tools covered in the talk I just gave. Any questions, I guess? That's the end. I don't have a closing slide. I thought I did, and I don't.